I've been volunteering with Coder Dojo for about 3 or 4 years now. And like Maria, I started coding when I was at uni as well. Andreas?
Hi, I'm Andreas. I'm actually a particle physicist, so that's how I need to look at data and play with code. And I've been with the Coder Dojo, I think, roughly the same time as Maria, about 2 years now.
I'm Richard Wisher. I've been with Coder Dojo for about the same length of time as Fiona, probably just behind her. We used to do coding within the public libraries in Peterborough, but since lockdown, we've been doing everything remotely. So we're now on our third term, and it's going great guns. So really good. I'm an aircraft engineer by background. I've got my own business, my technology business. So I'm very much into coding. That's what I do for my job. But paying something back and getting children or students to understand coding is super fantastic and gives me a great feedback. It's really important.
Grand. For our project, you're going to need a link, and I think Maddie's popped it in a chat for all of you guys. And we are going to So can you all see the Astro Pi screen now?
We can, Maria.
Okay, grand. So we're going to we're going to go through a bit of code, write up a few lines, because there's lots of data that astronauts need to know when they're out and up in space. So we're going to write a piece of code that can be run on the International Space Station to tell astronauts what the humidity of the reading is on board, and we're going to follow the instruction on AstroPi to do so. So our first I'll first show you what it does, and there's a little video here to do so. So the AstroPi is a little computer that sat in the rocket, and I think Richard has one as well that he can show you.
Yeah, I've got a physical one. So this is the it's a Raspberry Pi with a SenseHat on top. They call it an AstroPi. And obviously, to send into space, you've got to put it in a special container. But it's essentially just a Raspberry Pi with a SenseHat. And the projects when you do your project, like the project we're doing today, you send it to the European Space Agency, and they will load it up on the space station, and they will actually run your project. So that's the real. This is not just theoretical. The project you write today, if we lodge it properly.
Richard has one as well that he can show you.
Sorry, yeah. So that, if you see my screen there.
And we're going to need
Sorry, Maria, I'm not hearing you.
Looks like Maria is breaking up a little.
Maria, we're not hearing you. Don't know whether you're still speaking. The thing we always tell our...
Can you hear me now?
Yes, we can hear you now.
Okay. So we'll go on to the next page, and on this page you'll be able to see a link to a SenseHat emulator. If you'd like to click on that, we can start coding. Have we managed to get to this page? So from here, our first set of instructions is that you'll see a few lines that have been added automatically, and you're going to need these lines at the top of your code, and you're also going to type in a little message for the astronauts. So if you'd like to go ahead and start typing the code.
So the project is run. We're using a code called Python, which is a text-based programming language, which is very popular. Everybody uses it, but we're using it within a thing called an integrated development environment, an IDE called Trinket. So that's what you're in at the moment. You're in Trinket and you're programming Python. So that's.
Python is very popular with astrophysicists, in fact. So you see that you start by importing a library. Okay, so that is having all the functions of the SenseHat that you can see on the right. And you see Maria is just showing one of the available functions to actually show a message.
And what you also have by bringing in this library, you actually bring in an emulator. So the emulator you can see on the right-hand side, it's a full 3D model of the AstroPi. So you can actually tilt it and twist it and move it around. And you can see at the top, there's temperature and there's pressure, humidity, and you can actually set what those are within the space station. So in the emulator, you're setting the outside temperatures and pressures and humidities as well. And the little square, black square in the middle is where the information comes up, where we'll be putting up. Then you've also got a joystick and you've got some other buttons as well to select. So you can really do everything on the emulator. But when you send up to this ISS, to the International Space Station, it's no longer on an emulator. It's actually in a real Raspberry Pi. So the Raspberry Pi on the space station is actually measuring the temperature, humidity, and you're accessing that information.
So if
you click.
Go ahead.
Oh no, I was just going to click run so that they can see it do its thing.
Go for it. Moment of truth.
Let's see if this works. Oh, my computer's frozen.
Oh, there you go.
Yay! So now we've successfully got our first line of code in to our little AstroPi. We can move on to.
I say that's always a worrying point, but we have got it working now, so that's really good.
We can move on to the next part of the project. So we've pressed run and we've watched it read AstroPi out to us. And if you've noticed, you can either speed up or slow down how fast the text goes. And to do that, you're going to need a code called scroll speed. So if we go ahead and just do that now.
just to point out that that's a message that the astronauts would be able to see in the space station. So you can say something cool. And the change that Maria is now making is she's adding a parameter to her function call, right? So that she can change parameters of the message scrolling, in this case, to slow it down or speed it up.
It's quite cool to understand exactly what this message does. So the astronaut will actually run your project on the space station at a particular time in a particular place, and then you'll get a certificate back to say it was run by this astronaut. The astronaut will sign a certificate. And then on the back of the certificate, you'll get a map of the Earth, the orbit, and it will say and where your project was run. It will say your project was run over this place on the Earth at this height, at this date, at this time. This is what the astronaut saw.
So from here, we'll go on to the next part, and you can add color to your text. So we've got an example of some of the cuts of the color, the red, and that's numbers 255, 0 and 0. And you can use a color picker to help you find what colors you'd like. So you can pick your color and use the numbers in here to show your text in whatever color you'd like it to show. So we'll go ahead and use red. And in order to use that, you need to define the color before you put it into your code.
So right, colors can be made up out of basic colors. So in this case, we are using red, blue, and green. And the numbers are essentially the intensity for red, green, and blue. And if we want something red, then we just pump up red to the max. If you add a bit of green, then you get yellow. And if you mix in a few other colors, you can essentially make up almost any color that you want, as Maria has just shown you.
So the
Let's
RGB.
test this and see if this works.
There you go, red.
Yay! Sorry, should I kind of cut you out?
No, I was just saying something while you were doing it, and that's good. So let's carry on.
Okay. I'm hoping everyone's doing okay on the other end of things. Is there any Q&As or whatnot's come through?
No.
Okay. Our next step in this process is you can also add background color to your little AstroPie. So if you wanted to take some time and pick a color, all you'd have to do is define the color in your trinket. So let's just say you wanted light blue. You'd use or light green, shall I say? 186, 245, and 217. 186. I'm going to change that to green. And let's see if this works.
Okay.
So we've now got a background color for our text. We've now chosen a color for the text, and we've told it how fast we want the text to go. So if you guys wanted to have a go at changing the color and changing the speed, go ahead and do that.
What you're doing in a physical sense is you're actually putting this onto a screen, and the screen is 8 by 8, so 64 individual light bulbs, if you like. But these light bulbs are LCDs, liquid crystals. So you're addressing each individual LCD, and you're putting a color on that LCD, and by turning the lights on and off, you're getting the movement, the field movement or scrolling of the text through the lights. But you're actually addressing individual light bulbs, effectively, LCDs on your screen.
So, and if you wonder why Maria always checks that everything is working while programming, it's very easy to make a little typo or misspell a variable or something like that. And our computers are not as clever as we are. That means they don't understand in that case, and you will get an error. So if you've run into any errors, please let us know, and we will try and help and see what we can do.
And what we don't, everybody makes mistakes. Even we make mistakes. Maria very carefully has not made a mistake yet. But what we do in our code club, our code dojo, is that when our children on a Saturday are doing their coding, if they have a problem, if they hit a problem, I'm getting an error on this, they'll then show their work to us, and we'll help them. We won't tell them how to fix it, because they're not going to learn. But we can say, have you thought about looking at this? Have you thought about looking at that? So we'll guide them to the fixing of the problem. We won't fix it for them, but they will then know how to do that. So our youngsters that we have every Saturday are very adept at asking questions. The chat on here is actually, there's not much chat happening here, but on a Saturday, this just lights up. We have so much chat going on, and the kids just share their work if they've got a problem, or if they want to showcase to us what they're doing. And we learn from them as well. So we have a lot more interaction normally on a Saturday, and you're welcome to interact with us on the chat if you like.
Just to say, if you are playing around with speed, bear in mind that when the code is run on the International Space Station, it'll only run for 30 seconds, just because they're going to have loads of submissions. So they haven't got time to run really long programs from everybody. So you don't want to make it too slow, so that your code takes over 30 seconds to run. Otherwise, they won't see all of it.
So the next part in our little project is drawing an image or displaying an image in your little AstroPie. So as you can see here, they've got a little astronaut with a black background, and the astronaut is coloured in white LED dots. So to do this, you're going to need the colour codes for white, which is 255, 255, 255, and black, which is 000. And you'll also see part of the note says now is a good idea to give the color variables single letter names, because you're going to need to draw a little matrix for it. And you can use the little picture matrix that they've got here to create the astronaut, and you can probably play around with it so that you can create your own picture.
That's, by the way, exactly the same way.
So I'm now going to go ahead and put in.
Sorry, Maria.
Oh no, I was just going to say I'm going ahead and doing it so they can do it in the background. I'm hoping everyone's okay doing this so far.
If you can just drop us a little okay in the Q&A, or a not so okay if you're running into any problems.
You can see Maria there using one of the tricks, copying the code from the instructions. But hey, there's no problem with that. That's just every coder, every programmer. A good programmer is somebody who knows how to copy and paste, and knows how to take the advantage of build on the skills of others. That's not cheating. Coding in classroom, that would be cheating, but in coding it's not, because actually what you want to do is you want to build your experience on other people's experience, and you don't want any bugs. So the cleverest way to do it is to actually just copy and paste from the instructions, and it will work. I think a lot of children during lockdown have learned a lot of these skills, and there'll be a tremendous advantage to them later on in their education.
Just to let Maria know, we had a few messages of feedback, so I think people are following along. So thanks for letting us know.
Yeah, that's good.
Awesome. Now that I've put in a little picture matrix and I've used the astronaut, so you can see you've got black and white, the difference with B and W's. I'm going to add in a line so that it actually shows this picture. And the line I'm going to use is sense.set pixels picture. And that's not come up. Sense.set. And pop in picture.
Maria is typing that. What you're using Python. Python is what they call syntactic code. So it really matters where you put your commas, your dots, and the words you use. So it's actually every word has a bit of meaning to it. So it's a bit like learning a different language, but the language has got to be really precise. And although we're not seeing many errors here, you will get errors. And the trick is to work out where the error is and then fix it. So it's called syntactic programming. It's very powerful, but it's like a language. You've got to know exactly how to speak it. You've got to know how to put the commas in, put the quote marks and all that sort of stuff.
So now I've popped in my picture code and I've popped in a line so that it's going to show the picture. And as you can see on here, it's now got the little astronaut.
Cool.
So the next part of our project is to import another library, and that is it the time library or is it the sleep library? I'm going to let one of you correct me on this one. If I'm importing.
Sleep. Importing sleep from time. Oh, yeah.
Importing sleep from time.
I think that is correct. What
You're going to need to add. Oh, yep. You're just going to need to add that up at the top of your code, so that you can use it towards the bottom of your code. And now that you've got that, you can pop on the line below picture, sleep.
Libraries is a really important concept in Python programming. When you bring a library in, like Maria at the top, what you're doing is you're bringing in that entire library. So then you look at the library, you see what commands are within that library. All those commands are then available to you. So you can then, that's now where you're now doing, Maria is now accessing those library codes within that library, within her code. So that's the way you do it. You bring in Python, then you bring in the libraries that Python needs to use, and then you can use the commands within those libraries.
So now that we've got a picture, we're now going to move on to measuring the humidity.
So, and if you wondered why it is called a sense hat, it is because it can sense things like humidity, temperature, pressure.
It can also measure the position of the sense hat, so the AstroPy. So what you can do in the window, where where we set the temperature and pressure and humidity for the sensing, you can actually move the AstroPy around. You can actually twist it and turn it. So if you put your mouse over the AstroPy and then click and drag it, you'll see the AstroPy actually turning and moving. But what we're doing here, there's a whole lot of stuff going on here. This looks really simple. Maria's making it look really, really easy to do. But what you're learning about syntactic code. You're learning Python. You're learning variables. You're learning arrays of variables, and you're also learning libraries and functions within libraries. So you're starting to learn a whole lot of stuff about the fundamentals of coding and programming. So it looks simple, but there's a lot hidden in this. But I think what's amazing that just in sort of like half an hour of coding, showing you, you'll have created a project that will be uploaded onto the European Space Agency International Space Station, part of it, and it will be run by an astronaut in space. So how clever to put your code and your thinking and send it to a thing orbiting the Earth, and to be run in front of an astronaut who's sitting in that little capsule going around the world.
So what I've just done here is the humidity is recorded quite precisely, and the stored value will have a large number of decimal places, so you can round the value to any number of decimal places. So we're going to round it to 1 decimal place, and that's what I've done here. So I've used a bit of code to say round it to 1 decimal place. And now that we've got this piece of code, we need to write a line to actually show this message. And we're going to go ahead and using the sense show message for that.
If you think about a sensor pack like what we've got on the Astro Pi, it's not just gathering, it's measuring something, it's measuring temperature or humidity, and it's just coming out with a really accurate version of that. So it could be, here's humidity to 10 decimal points or whatever. To make that usable within your program, you've got to now constrain that. You've got to say, well, I don't want all these decimal points, and I just want the figure, and I want this level of accuracy. So you're having to constrain that data into information. And it's now the information that you're going to start displaying on your Astro Pi. There we go. 61.1. Was it 61.1?
I think so. That's because I've changed it over here. So you can go ahead and start playing around with what numbers you want it to show from up here.
Maria, can you just show them how to do the on the simulator? Can you just click and drag the simulator itself? No, that on the bottom, the actual object. That's it. Click and drag that. Yeah. So actually, you can move the whole thing around, and because it's a sense hat on board, because there's a sensor on board, it will pick up what direction it's pointing in and what its angles are. So actually, you can have a little. The display can be telling you what angle your box is at, or what speed your box is doing, or the G forces on your box. All that information is available in the sense hat on the Astro Pi. And it's a great simulator because also no matter what position you've got the box in, the text that you've got coming up on the screen will still come up on the screen in the angle that you're looking at it. So it's a really clever simulator. Yes, see? That's good. And by the way, I do a little bit of 3D printing. So we do 3D printing with our Coda Dojo, and we get the kids to do 3D models that I then 3D print them, and we give them certificates to say they've achieved a certain level of printing. One of my next projects is I'm going to do the case for the Astro Pi. So we have the case for the Astro Pi, which is called an STL file that I can now print. So we can actually have the STL file for the case and then put the Astro Pi inside the case. It will then fit in. So we can actually build our own Astro Pi in Code Club.
I'm hoping we're all good so far. And what I've done here is followed the instructions. But at the moment, it's just showing, if you remember just at the end, it's just showing the number. It was showing 61. Now if I do it again, it will show 33. In order to actually make that into a sentence, we're going to do something similar to what we did up here. And pop in the text to say, it is, use this bit of code to read the humidity, and then pop a percentage sign at the end. So I'm going to go ahead and do that. It's just so that it makes sense. So when the astronaut is actually reading it, they're able to tell it is whatever you've set your percentage up to here, humid.
Just to point out a few things, obviously humidity is an important thing to know in your space station, because if it is very humid, then your electronics might malfunction. And as your life support depends on the electronics, you want to make sure that everything is nice and dry up there. And also, if you look into the construct that Maria is showing you, right, you see that she can't just sort of show the message in the same way that you would actually say it. There is a bit of syntax to be taken into account. So in particular, our humidity is a number, and we need to transform that into a string of text. So there's a bit of difference. And you see that we can add the different pieces of text together with just a plus sign. Back to you, Maria.
Thank you. So if you guys want to go ahead and do that and then check your code as you're doing it as well, that'd be cool. And you can have a bit of a play around up the top here to change the number. And every time you change it up here, you'll see that number appear in here. So we should see 33 or something along the lines of 33. 34.2, yep, that'll do.
And it's interesting,
so we're doing well.
It's interesting the next bit as well. When you hear 36.2 or whatever the humidity is, what does that mean? So if you're like me, I've got absolutely no idea what 32% humidity means. Does it mean it's really dry? Does it mean it's really wet? Whereabouts is that? And because we don't use it that often, we don't really know. So the next part is really clever, where it actually says, let's show you a picture of what that humidity means. So, and given that pictogram type picture, immediately sets in your head that this is like the humidity you would experience in a desert, or this is sort of the humidity you could experience in a fish tank. So actually it gives you some context for the data, because I don't know whether 36.1 is good and 36.4 is bad. So I need something to actually put it into my brain. So a pictogram or something graphical or an image really works in the human brain. The human brain will pick that up. Like if I've got a big green button comes up in front of me, it's green, so hey, that's okay. If it comes up a big red button, you think, oh, something's wrong. I've got to start worrying, but what have I got to worry about? So getting the context and getting the messaging right is so important. It's really good, really important for computer systems as well. You don't give people lots of data, you give them clear instructions or clear indications of whether something's working or it's not working.
So for our next part of code, they've given us some colors to work with. So you can either go ahead and copy and paste this, or you can make up your own. I'm going to go ahead and copy and paste it. And I'm going to need that bit of code before I use it in the picture, which I'll copy and paste at the bottom. So the colors I have, I think, are orange, blue. Does someone want to help me out with what C stands for?
Cyan, maybe?
And E. We'll go with Andreas. What Andreas has said. E. What does E stand for? Color-wise. But G is green and Y is yellow, so we've got those two.
E seems to be something grayish, but that obviously doesn't start with E.
I was I was watching a fascinating program. I was watching some of the live feeds from the Mars lander the other day, and they're doing some fantastic stuff with imaging. I'd have a look at it, and when you see that we're doing sort of fairly simple imaging here, but when you start taking big images and you're dealing with imaging, it's there's a fantastic coding and science experiments being done in that space.
Because I've got two variables which have the same letter B, I'm changing the top one that's black to BL. I'm going to change it up down the bottom in the picture so it reflects that as well.
And meanwhile, if you can let us know if everything is going fine for you or if you run into any problems, that would be great. Thanks.
I think the challenge for West Suffolk College and all the people on the call is that we should be trying to do some sort of world record and trying to put the most number of space missions up from West Suffolk College over the next couple of days. Remember, the European Space Agency and NASA guarantee to run every project that's sent, which is a big ask. But if you send up, if everybody on this call, I don't know how many people there are, but there's certainly a few classes on the call. If every person in every class puts their project up, then effectively we could have launched something like, say, 200 space missions from West Suffolk in one day, and we might actually get a record. Last year we did Peterborough Coder Dojo, and we also had a STEM festival. And I think we submitted the most number of projects from a single city in the UK. And I think West Suffolk College need to be challenged to see if they can do better than us than we did last time.
And remember that you can tell the astronauts actually that it is West Suffolk College codes that they are seeing at the moment.
Yeah.
So now that the code that I've just added onto here will give me these two pictures of a cactus and of a fish. So, so now that we've got these pictures, we now have to, well, we can now go ahead and use it. And we've defined them as wet and dry. And we've already got the humid code. Oops. Oops. Why is this not working? There we go. We've got the we've already got the humid code in our little Sense Hat emulator, and that is over here. We've just got the rounding function in it. We're now going to use an if and an else bit of code. And so if the humidity is less than 40, it's going to show wet. Otherwise, it's going to show dry.
That's greater than or equal
to. So let's go ahead. Okay.
think that's greater than or equal to 40. So if our humidity is high, then we're wet. If it's low, then we're dry, because the humidity means the amount of water that we've got in our air.
This is why we need Fiona here. So we're going to go ahead and add this bit of code to our little space thingy. So we've already got the humid line. So we just need to add the code if humid is less than or equal to, or more than or equal to. I never know which way around I'm supposed to read this.
That's the way it looks like.
More than.
One of the things I could just mention while we're doing this is that we're using the Mission Zero version of the AstroPi project, which is a simple project. It's a small amount of code that they guarantee to run. There's another thing that sits alongside it, which is a major challenge, where schools can actually put in a request to run a bigger project over a period of time on the ISS. And you can see, if you look at the AstroPi website, you'll be able to find that information. So school teachers, maybe a bit late now in this term, but worthwhile thinking about, you can actually maybe pick up on one of these larger projects and actually turn it into a major science experiment where you can actually, over a period of time, run something using these tools on the International Space Station within a science class or a science forum. That's competitive, so it's the best projects get run on that one, not everybody's. So if you've got some of the best projects or some of the best project ideas, you might be able to get yours up and running. And that would be a fantastic outcome from this little demonstration today.
So I've gone ahead and put in my if line. There's my little astronaut bit running. It's going to tell me it is 34.2. And that tells me it's dry.
The desert. It's a cactus in the desert.
If I go ahead and change this to a number above 40, have a think about what picture it'll show and why.
You can, of course, modify the pictures. So that is as a challenge to you. I'm sure you have artistic talent. So if you can come up with a picture that shows dry a bit more clearly than our rudimentary cactus, please go ahead.
This is where this project, coding is behind it all, but in front of it all is engineering, there's science, and there's also there's art and craft. So there's a lot of art goes into these in terms of what you can design, and graphics and art is a very big part of what we do within Coder Dojo. We've done sort of pattern making and all that sort of stuff, and it's so art is a big part of it. It's not just STEM anymore, it's STEAM. So there's an A within STEAM, which is the art part, the artistic part. It's all creative. Creatives and science goes together these days.
The handy little thing about using this one, and to check that if it will actually go into the space station, is that all three of these need to be green. So whilst you're doing your different pictures for wet, dry, or even little picture up at the top, you can check that it's doing what it's supposed to do if all three of these are green.
So you haven't got any errors on there, Maria. So why is it not saying yours is run your program without any errors?
Because you have to run it, and once it's done its run, it'll come up green
Okay.
at the bottom here.
Okay, cool.
So it's still running. It's been doing it for about 20 seconds. I think Fiona mentioned it has to be under 30 seconds in order for it to go onto the space station. And this has come up green because it's under 30 seconds. Yay! I'm hoping you will manage to successfully complete your projects too. Do you want to give us an okay in the chat box or the Q&A?
So this is Launch Mission Control saying green is go. Well done, Maria. We're ready to launch. So you're ready to now put it into the, can you show them how to do the continue into the form and then how to submit? Is that green button at the bottom?
Yep. Yes. So the code that you're going to need to submit your work is going to be STEMtastic 21.
Yeah.
STEMtastic 21, and once you've typed that in, you just go continue to form. You can either pop a team name or your name in there. And go ahead and fill in the details here.
I think you can, this might be your opportunity, Maria, to make yourself a bit younger.
Yes, I'm just about to do that. I'm going to go with 10. Pop that in. So I've got a team name, I've got a member name. I can add another member. We'll pop Fiona in as well. We'll pop Richard and Andreas. If you've done it with somebody sat next to you, you can all pop your name in there. Sorted. And submit. And that's it. That's now going into space.
We have an official submission and we have launched into space. So this isn't Elon Musk launching his starships, this is us launching our program, and it's heading towards the ISS, and it's going to be run. It's not run immediately. I think it's over a period of time, isn't it? Because you got a lot of submissions. So I think you got to wait for maybe a few weeks or maybe even a month or so to get your information back. But it is launched and it's on its way.
Yeah, so the certificates will be sent to the teacher at West Suffolk who registered to get the classroom code. So if you just look out for that in your email. If anybody else who wasn't on the call today wants to have a go, the deadline for submission is the 19th of March. So there's only about a week to submit to get your certificates.
Also, if you haven't quite finished today, a cheap method to save your work would be to copy and paste this into a Word document, and then you can finish this off later. And the only info that you're going to need to do this is the site with the instructions and the STEMtastic 21 code to submit your work.
Some of the innovation.
Check, however,
I was just going to say some of the innovation in this is not as much as we would normally do on a coding project, but this is quite specific. It's quite tight. So the specification is quite tight. It's got to be run by a certain in a certain amount of time. It's got to be in a certain way. So yes, you can play around a little bit around the edges, but more or less it's a straight project that we've shown you today. But by doing that and launching it and getting it run on the space station, that to me is a major achievement. So you want to do it more or less exactly the same way as they've specified, but you might play around with it a bit. You might change some of the pictures. You might do a few little changes, but you are quite limited in what you can do in terms of changing the thing. But if you're interested in the Raspberry Pi project like this, if you go onto the Raspberry Pi Foundation website, projects website, and you look at the Sentat projects, there's a whole range of Sentat projects on there that you can access and you can run and you can really play around with. So what you've learned here is applicable to all those Sentat projects. So if you look there at projects, and there's some really good, one of the things we do in Code Club, but it's exactly, it's Code Dojo, but it's exactly the same at school. There's a whole range of content now that's available, lots of different projects and lots of things you can do. And Maria's taking us to the project page on the Raspberry Pi Foundation, Code Dojo.
I'm not sure if I can hear anyone or if it's gone quiet.
No, I can hear you. It's all right.
Seems slightly frozen, Maria.
So these are the Code Dojos. This is the way you find us and find all the Code Dojos. Code Dojos and Code Clubs are the same sort of thing. Code Clubs are more or less done at school. Code Dojos are done in libraries and other places, but the content is the same and it's still under the Raspberry Pi Foundation. But the content, the sort of projects you can do are very wide ranging. And with resources, if you look at resources, you can get into physical computing. That's what we've been doing today. And you'll be able to see the a whole range of projects that you can do. And they're very well documented, very well explained. There's help for teachers as well. If teachers want to do it, there's additional content that helps teachers with how best to explain this to a class. And as you can see, the projects themselves are really exciting, and you can do some quite cool stuff. And in fact, our group, we also are in our Code Dojo. A lot of our students, we're going to be doing a thing called Coolest Projects, and of course that's available to schools as well, to Code Dojos, and that's where you can put your coolest project up and you get it judged by other people and by experts. So Maria's now got the projects, and here you can see you can go in and you can look at all the projects. And the thing, of course, that we're interested in is the hardware. So if you go into any hardware, you go into the hardware one. There we go. And see Sentat. If you go down to Sentat, that's what we've been playing with. So Sentat is the option there. No, it's under hardware, Maria.
Where's Sentat?
No, it's under hardware. The next,
okay.
That's it, yeah. And then it's halfway down.
There we go.
That's it. So these are just some of the projects that you can now do with that Sentat emulator. You don't need the physical hardware. I've got the physical hardware here, but it will work just the same on a simulator, an emulator.
I think the Flappy Bird is something that I might have to try out.
And I think that kind of brings us to a close to our session. So I'm hoping you guys have learned something in this session.
This has been absolutely brilliant. Thank you to all of you from Coder Dojo. It's been really good. As I said, I love Raspberry Pis. I actually don't have any students with me today. Today's my sort of slightly admin day, but I'm definitely going to get onto them next week and watch these back and get them to have a go at some of this as well. So thank you so much. It has been great, and hopefully everyone at home at school has enjoyed it as well. Thank you.
Thank you.
Thank you. Thank you very much for having us.
Thanks.